So let's practice this. So describe the graph of how this can be transformed. This is what I will refer to as the parent function. It is the most basic original part of that. So how did we go from the parent function? How did we go to this? So first of all, is it done inside or outside? Outside. So is it vertical? And it's -4. So that tells me we're going down 4. Now the next one, is it done outside or inside? Inside. So it is a horizontal. And it's the horizontals are always the opposite. So we're going to go to the left 2. Are we okay with those kinds? Okay. Example 2, I'm going to do something kind of fun. So the original equation, the original function they tell us is x cubed. It's the cubing function. And they give us pictures and we got to figure out how we translated them. So here we go. So the red dotted one is the original. So how did we go from the original to the blue one? Down 3. So that's a vertical, so it's on the outside, right? So I'm going to say x cubed minus 3. Now what about here? 2 to the left. So it's done inside with the x. So I got to go plus 2. Do you see how we did that? Oh, the red is the original. The red dotted. The original function is the cubing function. It's that's what we're starting with. So now the third one, can you see it? Yes. So we went to the right 3. So it's a horizontal, so it's done in the parentheses with the x. And we got to make it look the opposite of where we want to go. So are we okay with those 3? Yeah? Okay. The next thing we're going to talk about is reflections over the axes. So if we started with a point at xy, that is where we start. And we want to reflect that point over the x-axis. Does the x part change or the y part change? The y part is what changes. Over the x-axis, flips it, makes it live here. So it means we make the y negative. Is that okay? And what about if you flip it over the y-axis? The x changes. What if you did over the origin? They both change. Over the origin puts us down over here. So it's like we reflected to here and then we reflected to here. So over the origin, they both change. If it's an odd function, so it's reflected through the origin, they both change. And that's not listed up here, but it will be on the next page, which is why I threw it in there. Are we okay there? So now let's go to page 3, which is actually the front page. Awesome. It was, I gave it to him wrong, in the wrong order. It's my fault. But we're smart. We can figure it out. So across the x-axis, when we graphed it, we noticed the x value didn't change. So you notice the x in here didn't change. The y was negative. So you put the negative on the outside. Through the y-axis, the outside, the y didn't change. It was the x that became negative when we reflected it. So they put the negative on the inside. And through the origin, they both changed. So there's a negative on the outside and to the x. So let's practice it. So find an equation of this reflected across each axis. So let's do the x-axis first. So the x-axis, the negative, is on the outside. It's negative of the function. So I'm going to go negative my function. But we're not going to leave it like that, of course, because that would bother us to leave it like that. Nope, we're not going to. So, when we have this, especially with fractions, a lot of times I'll see people bring the negative through the top and to the bottom. But if you bring a negative to the top and the bottom, did you multiply by -1? No, really you multiplied by a 1. So when you're multiplying by negative and you have a fraction, think of this as -1 over 1. So the negative is only going to go to the top or the bottom. We usually bring it through to the top. So what would the top look like? -5x plus 9, and the bottom will remain the same. So that's the equation of it reflected through the x-axis. And now we're going to do it through the y-axis. So y equals f of -x. So we're going to replace all of our x's with a -x. So on the top, what do you get? So it'd be, so eventually you're going to get -5x minus 9. What about on the bottom? X squared plus 3. And there it is. There they are reflected. Are you okay with that? Okay. Huh? They said around the axes. So those were rigid transformations. So now we're on to non-rigid. This is where the page 4, next page. So we last year did vertical stretches and shrinks. We never talked about horizontal stretches and shrinks. We are now going to talk about horizontal stretches and shrinks. Okay. So let me do something really quick. If I had x over 2, that stays as x over 2, right? But what about 2x? Could I write that as x divided by something to give me a 2x? What would I divide this by to get the 2 up here? A half. You divide it by a fraction, right? Because x over 1/2, we don't like that. We rewrite that as 2x. What if I had 5x? Could you write that as x divided by what? 1/5. It's the reciprocal, right? What if I had 5/2 x? How could you write that as x divided by 2/5? Okay. The reason I'm making us think of it this way is for horizontal stretches and shrinks, it's x divided by our c. If c is greater than 1, that is a horizontal stretch. If c is less than 1, that's a horizontal shrink. And so if you had x over 2, in our minds that looks like divide by 2, right? So we're like, oh, it's a shrink. But remember, horizontal is always opposite of what you think. So you're really looking for the c value. And what's the c value right here? 2. And so that would have been a stretch. Where if you had 2x, you would have to think of this as some x divided by something. You would have this as x over. So this is less than 1, so that's a horizontal shrink. So always the opposite of what it looks like. Is that okay? We'll do examples. Vertical is what it does what it says. It's on the outside. It's your constant. It's a number times your function. And so same thing. If c is greater than 1, it's a stretch. If c is less than 1, it's a shrink.
You have two c's.
Hmm?
What if you have c times the function of x and x over c?
I don't think we're going to do that to you. So let's practice. So here's my starting function. It's x cubed minus 16x. And for part A, they want us to do a vertical stretch. So vertical is the number times the function. And they want us to vertically stretch by a factor of 3. So our new function is going to be 3 times my original. So you're going to distribute the 3. So you have 3x cubed minus 48x. So that would be a vertical stretch of 3. Is that okay there? And then for part B, they want us to do a horizontal shrink by a factor of a half. So the horizontal shrink, what that means is I'm going to take f and I'm going to go x over divided by your c value. But instead of thinking of that as x divided by half, what's x divided by half look like? Looks like 2x. So I'm going to replace all my x's with a 2x. So what's 2x cubed? 8x cubed. Minus, what's that turn into? Oh, good. There it is. Is that okay? Okay. Example 6. We're going to do some transformations. We're going to do it in a specific order. And then the next part is we're going to undo it. We're going to do them in the reverse order and see if it matters. We're really going to look and see, does order matter? So, we're going to start with x squared. That's our parent function. And now this one tells us to do a horizontal shift 2 to the right. So how do I write that?
Like the coordinates for it?
Nope.
Then the function.
So y equals, that's the first thing. So now we're going to take that one that we just made, and now we're going to do a vertical stretch by a factor of 3. So how do we do the vertical stretch of factor of 3? So we're going to go 3 times x minus 2 squared. And then the last one in our final function is going to be then we're going to take that and we're going to vertically translate it up.
The whole function by 5, or add by 5.
Add by 5.
I remember this.
So this is the final equation of our function with all those translations.
Life makes so much more sense.
Oh, I was doing this was the first one, this was the second one, this was the third one. And that was just for me to keep them in the right order. And now part B wants us to do it in reverse order. So what's the first thing? What's our first miniature equation here? We start with x squared and we're going to go, what's this one tell us to do?
Add 5 to the equation.
So x squared plus 5. And now I got to do the next translation.
Multiply the whole thing by 3. Well, the function by 3.
So that's the vertical stretch. That's the whole thing by 3. And the last one is going to tell us to do the shift, yes? So y equals 3, and then we have x minus 2 squared plus the 5. Do these give us different results?
No.
What happens if you distribute that 3?
Oh,
That'd be a plus 15. Up here, what is it? Just plus 5. Does order matter?
Yes.
Order matters. That's what they're trying to show you. Are we okay with transformations? Okay. And the last one is all about, they give us a picture, and I'm going to show you what the picture looks like. And we got to move it. So I went, I think 5 by 5. I think down I went by 6. I went down 6. So we are going to move it. And the picture they give us in the book is not really a function, which is why they don't give us an equation. And when I graph these and I have to move a picture, I'm going to have like key points that I move. All right. And these are the key points they give us in the picture. And this is like a quarter of a circle right here. And then this is a straight line. So it kind of looks like half of an ice cream cone on its side. So that's the picture. And now they give us this, and we got to do the translations. So what's that 2 on the outside tell me to do? It's a outside, so it's a vertical stretch by 2. So now is vertical, it's only stretching my y values. So the y value here is 0. So what's 0 times 2? 0. Now this one's the y is at 2. What's 2 times 2?
4.
So that one gets stretched up. 2, 3, yeah, that's right. And this one, the y value is 0, so that stays there. So right now, it got stretched out. Are you okay with the vertical stretch part? And then I just read left to right. So then I have the plus 1 on the inside. So that means it's a left. It's a horizontal, and it's the opposite, so left 1. So I'm going to take all my points, and I'm going to move them back 1.
You have to draw a picture on each step.
I would. If you have colors, this is a really good time to use your beautiful colors. Or if you're using a pencil and you're getting too confused, I would maybe erase the other ones. So, there we go. That's where I'm at. And what's the last thing tell us to do?
Go down 3.
Go down 3. Move all your points down 3. And there it is. That's your final. That's it.
Thank you.
It's our final picture of the day for this hour. So, are you guys okay with the picture part? You just move it how it says?
Yeah.
And there's your homework.